So we are dealing with the sixth problem in this segment, and the problem is problem number 1.31. The problem is stating a ball starts falling with zero initial velocity on a smooth inclined plane, forming an angle alpha with the horizontal. Having fallen a distance h, the ball rebounds elastically off the inclined plane. At what distance from the impact point will the ball rebound for the second time? So if we start approaching this problem, the first thing to understand is what exactly the question is talking about. So in order to understand that, we first construct an inclined plane to explain the situation of the problem. So if this is the inclined plane we are talking about, this is the angle of inclination of the incline which is given to us as alpha. Now from a point which is at a height h above the ground, the ball is dropped, which makes an impact somewhere here. So at the point of impact, we again draw a line of normal to mark the different angle of rebounds, the different velocities of rebounds technically. So over here at this point, when it strikes, it is having a certain speed, let us say u. Now since it fell down by a height h after being dropped before making the impact, we can write from here that u equals root over 2gh. Now at this point when it is making an impact, so this angle will become alpha, and hence we can say that there will be two components. One component will be this, which is equal to u cos alpha, and the another component will be this, which is equal to u sin alpha. So now at rebounds post the particle hits the plane, since it is elastic collision, the component of velocity u cos alpha will remain unchanged, and after the impact we are having these two velocities which are equal to u cos alpha and u sin alpha respectively, and now it will rebounds in a way like this and will strike the inclined plane here. So now in the problem it is asked to calculate this distance r at which it is going to rebound for the second time. If we talk in terms of acceleration due to gravity, so acceleration due to gravity is g in the downward direction, and we have two other component, g cos alpha in this direction and g sin alpha in this direction. So if in this problem we select a coordinate system, so let us select a coordinate system. This one is x-axis and this one is y-axis, and now let us start approaching the problem by saying that we will have a component along x-axis. So this one is along x-axis and the another one is along y-axis. So if we talk in terms of along x-axis, so initial velocity in the x-axis direction is equal to u sin alpha. In the downward direction, downward we are taken as positive. Acceleration in the x-axis direction as g sin alpha. Displacement in the x-axis direction as r, which we want to calculate, and time is t. For calculation of time we are taking along y-axis, so initial velocity in the y-axis direction is equal to u cos alpha. Acceleration in the y-axis direction is equal to minus g cos alpha. Displacement along y-axis in the entire duration of motion will be 0 and it will take another time t. Since both the motions are taking place simultaneously, the time duration for both the motions are same. So if we solve along y-axis, So we can say that displacement along y-axis is equal to initial velocity along y plus half acceleration along y t square, and therefore we can say 0 equals u cos alpha t minus half g cos alpha t square, and over here on solving we obtain t equals 2u cos alpha by g cos alpha. So cos alpha cancels out and we get this time t. This is not the answer to the problem. The problem has asked us to calculate r, that is we need to solve along x-axis as well. So along x-axis we say displacement along x-axis is initial velocity along xt plus half ax t square. So since we are solving for range r equals 2u square by g sine alpha plus half of g sine alpha and then t square, that is 4u square by g square, and over here we obtain 4u square sine alpha by g. So if we substitute the value of u equals root 2 gh, so we get the final answer for the problem, and it is equal to 8h sine alpha. So this is the answer to the problem which we have discussed, problem number 1.31.